Good morning, students. Last time we have seen the rules used for the IUPAC nomenclature of coordination compound. Now we are going to apply this rule by solving some examples of coordination compound or by giving IUPAC names for coordination compound. Now first we start from this example. Now these are the compounds containing complex anions and metal cations. Now here we have divided all these compounds in 5 categories, in which first we are going to see anionic complex, that is complexes having negative charge. Then secondly, compounds containing complex anions and metal cations, that is here these are the complex anions and these are metal cations, like this. Then we are going to see the complex, that is cationic complex, that is complexes having positive charge. Then we are going to see compounds containing complex cations and anions. Now look here, it is complex cation, that is this complex have positive charge, and this is these counter ions are negatively charged anions. Same thing here. And then we are going to see the neutral complexes, that is the complex which do not possesses any charge or chargeless complexes. Now like this, that is CONO2 3 times NH3 3 times. Now this coordination sphere does not possesses any charge and therefore it is a neutral complex. Same thing here. Now we are going to see the first compounds containing complex anions and metals cations. Now look here, first we have to calculate the oxidation state of central metal ion. Now here the central metal ion is aluminium. This fluorine, that is 6 fluorine are the ligands, and this sodium is a metal cation. Now here we are going to calculate first oxidation state of central metal ion. Now consider the oxidation state of metal ion is X. Then here there are 6 ligand, and here this fluorine possesses -1 oxidation state and this Na3 possesses +1 oxidation state. Now here there are 3 sodium, therefore write 3 into +1 plus X plus 6 into -1. Now total oxidation state of this coordination compound is 0. Therefore here X is equal to 6 minus 3 is equal to +3. That is oxidation state of aluminium in this complex is +3. Now we are going to give the name. Now it is anionic complex. Therefore we write the metal cation, name of metal cation first, that is sodium. Now write the name of ligand. It is fluorine or fluoride. Therefore we write fluoro, and there are 6 fluoride. Therefore we have to write hexafluoro. Now it is aluminium, but it is an anionic complex. That is, if we remove this Na3 or these 3 sodium, then it acquires -3 charge on it, and therefore this complex is anionic complex anion, and therefore we have to write name of aluminium like aluminate, that is sodium hexafluoroaluminate. Now here oxidation state of this aluminate is 3. Write this 3 in its parenthesis 3. This is the name of this complex, that is sodium hexafluoroaluminate 3. Now we are going to give the name for this compound, that is K3AlC2O4 3 times. Now this is K3AlC2O4 3 times. Now here first we are going to calculate the oxidation state of this aluminium. Consider this as X. Now here this is C2O4, that is oxalate. Now it possesses -2 charge, and there are 3 oxalate, therefore multiply this -2 by 3. Now this is K3, that is potassium possesses +1 charge, and there are 3 potassium, therefore write 3 into +1 plus X plus -2 into 3 is equal to total charge on this complex is 0. Therefore here it becomes X is equal to +6 minus 3, therefore the oxidation state of aluminum is +3. Now it becomes, name of this complex become, now here it is metal cation is potassium, therefore write first name of potassium. Now here there are 3 oxalate ion, therefore it write here trioxalato. Then here aluminate and write the oxidation state 3 in its parenthesis. That is, name of this complex is potassium trioxalato aluminate 3. Now we are going to see the next example, that is Na3CO NO2 6 times. Now first calculate the oxidation state of central metal ion, that is CO. Now consider this oxidation state as X. Then here there are 6 NO2 group, therefore 6 multiplied by -1. The charge on NO2 group is -1, or oxidation state of NO2 group is -1. And here there are 3 sodium, oxidation state of sodium is +1 multiplied by 3, total charge on complex is 0, therefore it becomes X is equal to 6 minus 3 is equal to +3. Therefore oxidation state of cobalt is +3. Now write the name of this compound. Now here it is sodium. Then hexanitro. Then it is cobalt, but it is anionic complex, therefore it becomes cobaltate. And here 3. 3 is the oxidation state of this cobalt. This is the name of this complex, that is sodium hexanitro cobaltate 3. Now we are going to see the IUPAC nomenclature of anionic complex. Now here we are going to see this third example, FeCN6 4-. Now first calculate the oxidation state of central metal ion. Central metal ion is Fe. Consider the oxidation state of Fe as X plus. Now here there are cyano group or cyanide group. Oxidation state of cyanide group is -1. There are 6 cyano group. Therefore multiply this by 6 is equal to. Now here this coordination ion possesses -4 oxidation state. Therefore write X plus -6 is equal to -4. Therefore it becomes X is equal to 6 minus 4. Therefore oxidation state of ion is +2. Now we are going to write the name of this complex ion. Now here there are 6 cyano group. Therefore write hexacyano. Now here it is ion, but it is anionic complex, that is negative charge on complex. Therefore it becomes ferrate. And oxidation state of this ferrate is +2. Therefore write here +2. And here it is complex ion. Therefore write here ion. That is, here there is presence of negative charge. Therefore it becomes hexacyanoferrate 2 ion. Now we are going to see this second one. Now first we are going to calculate the oxidation state of this cobalt. Now consider the oxidation state of cobalt as X. Now here there are 3 oxalate ions. Now the oxidation state of oxalate ion is -2. Now there are 3 oxalate ion and total number of charge on this complex is -3. Right here -3. Therefore X is equal to 6 minus 3 is equal to +3. That is, oxidation state of cobalt in this complex is +3. Therefore name of this complex is trioxalato cobalt 3 ion. Trioxalato cobaltate 3 ion. It is anionic complex, therefore write ATE at the end of the metal ion. Now first one, NiCN4 2-. Now first calculate the oxidation state of central metal ion. Now it is nickel X. Consider the oxidation state of nickel as X. Then here there are 4 cyanide group and oxidation state of cyanide group is -1 and total charge on complex is -2. Therefore X is equal to 4 minus 2 is equal to plus 2. That is oxidation state of nickel in this complex is plus 2. Now write the name of this complex. Now here 4 cyano group are present. Therefore it becomes tetracyano. Now it is nickel, but it is anionic complex, therefore it becomes nickelate. Now oxidation state of this nickel is plus 2 and it is ion, therefore it is tetracyanonickelate 2 ion. This is the IUPAC name of this complex. Now we are going to see the nomenclature of these complexes. Now here this RH is, first we are going to see neutral complex. Now this RH is nothing but rhodium. Now this central metal ion is bonded to 3 ammonia and 3 thiocyanate group. Now here it becomes, now first calculate the oxidation state of rhodium X, then here NH3 group is present, 3 NH3 group present and oxidation state of NH3 is 0 because it is molecule, plus here the oxidation state of this thiocyanate or SCN is -1 multiplied by 3 is equal to total charge on complex is 0 and therefore X is equal to plus 3. That is oxidation state of this rhodium is plus 3. Now here it is example of heteroleptic complex. That is in this coordination sphere central metal ion is bonded to or coordinated with 2 different types of ligands. That is one is amine and second is thiocyanate. Alphabetically amine come first. First therefore we write it is triamine, thiocyanate, then rhodium, then oxidation state of rhodium is plus 3. That is triamine trithiocyanato rhodium 3. This is the name of this complex. Now we are going to see the 14th one. Name of this complex. Now it is FeCO5. Now here this Fe is attached to 5 carbonyl group. Now the oxidation state of this carbonyl group is 0. Oxidation state of ion is X. Here oxidation state of carbonyl is 0 multiplied by 5 is equal to 0. Therefore oxidation state of ion is 0. Now name of this complex is. Now here there are 5 carbonyl group, therefore it becomes pentacarbonyl. Now it is ion, IRON ion, and oxidation state of ion is 0, therefore write 0 in the bracket. Now we are going to see 13th one. CONO2 3 times NH3 3 times. Now here this is also example of heteroleptic complex, that is this central metal ion is bonded to 3 NO2 group and 3 NH3 group. That is the coordination number of this central metal ion is satisfied by 3 NO2 group and 3 NH3 group. Therefore the oxidation state of cobalt becomes X plus, now here NO2 group, oxidation state of NO2 group is -1 multiplied by 3 plus oxidation state of amine is 0 multiplied by 3 is equal to total charge on complex is 0. Therefore X is equal to plus 3. That is here oxidation state of cobalt is plus 3. Now we write the IUPAC name of this compound. Now it becomes, now here it is nitro group and it is amine group. Alphabetically amine comes first, therefore it becomes triamine, trinitro, cobalt 3. This is the IUPAC name of this complex, that is triamine trinitro cobalt 3. Now we are going to see 12 number, that is compounds containing complex cations and anions. Now here this complex possesses cobalt as a central metal ion. First we are going to calculate the oxidation state of this central metal ion. Now here it is also heteroleptic complex which is bonded to one H2O. Oxidation state of H2O is 0. Now here amine, 5 amine are present, but the oxidation state of ammonia is 0. 5 multiplied by 5 plus there are 3 iodine atoms, therefore it becomes X plus 0 into 1, 0 into 5 and 3 into minus 3 is equal to total charge on this complex is 0. Therefore X is equal to plus 3. Therefore oxidation state of cobalt is plus 3. Now we are going to write the name of this complex. Now here there are 5 amino group and 1 aquo group, but alphabetically amine come first, then aquo come first. Therefore it becomes pentaamine aqua, water is named as aqua, cobalt 3 iodide. For these 3 iodine or 3 counter ions we write iodide. Therefore name of this complex becomes pentaamine aqua cobalt 3 iodide. Now we are going to see this 10th example. Now here this is platinum as a central metal ion. Now this platinum is bonded to 2 different types of ligands, that is bromine and ammonia. Therefore it is example of heteroleptic complex. Now here oxidation state of bromine is -1. There are 2 bromines, multiply by 2, plus here there are 4 amine group and oxidation state of amine is 0. Now here there are 2 bromine also present. Oxidation state of bromine is -1 multiplied by 2 is equal to 0. Now we get the oxidation state of this platinum as plus 4. That is it becomes 0, -2, -2, -4. When goes on that side it becomes plus 4. Therefore oxidation state of platinum is plus 4. Now we are going to write the name of this compound. Now here there are 4 amine group and 2 bromo group. Therefore it becomes tetraamine dibromo platinum 4 bromide. This is the IUPAC name of this complex, that is tetraamine dibromo platinum 4 bromide. Now we are going to see the nomenclature of cationic complex. Now first this one. Now first calculate the oxidation state of platinum. Oxidation state of platinum, consider it as X. Now oxidation state of EN. EN is nothing but ethylene diamine. It is 0. There are 2 ethylene diamine plus oxidation state of this SCN, that is thiocyanate, is -1. There are 2 thiocyanate. Therefore write 2 is equal to oxidation state of this cationic complex is +2. Therefore X becomes +4. Therefore oxidation state of platinum becomes +4. Now name. We are going to give the name of this complex. Now here there are 2 amine ethylene diamine group and here SCN, that is thiocyanide group, are 2. Now ethylene diamine is bidentate complex. Therefore we have to write name bis ethylene diamine. Dithiocyaneto. Now platinum, oxidation state is +4 and iron. That is, name of this complex is bis-ethylene-diamine dithiocyaneto platinum 4 iron. Positive charge is there, therefore write here iron. Now we are going to see this 8-1. Now first calculate the oxidation state of iron. Consider it as X. Now here there are 5 H2O, that is aqua group. Now the oxidation state of H2O is 0. Then multiply by this 0 by 5 and this is isothiocyaneto group, that is NCS. Now the oxidation state of this NCS is -1 and number of this NCS is 1 and total charge on this complex is +2. Therefore it becomes X is equal to, now it becomes 0, this is +2, it becomes +3. Therefore oxidation state of this ion becomes +3. Now we write the IUPAC name of this complex. Now here there are two types of ligands are present, that is central metal ion is bonded to two types of ligands, that is aqua and isothiocyaneto. Therefore we write the name as penta aqua isothiocyaneto ion. Bracket मध्ये in bracket write down oxidation state +3 ion. That is, name of this complex is penta aqua isothiocyaneto ion 3 ion. Now we are going to see this last one, that is CuNH3 4 times 2 plus. Now the oxidation state of Cu is X plus oxidation state of this amine is 0 multiplied by 4 is equal to +2. Therefore X is equal to +2. Now here it is, the oxidation state of copper is +2. Therefore name of this complex is tetraamine copper 2 ion. In this way, IUPAC names for the coordination compounds are given.